We like to use ice cores because they provide this sort of time capsule of deposition of pollutants to the Arctic. So it allows us to learn a lot about trends in their deposition. So from our two ice cores, we ended up with about 4 decades from one ice core and 5 decades from the other ice core. And this allowed us to see trends in deposition from the 1960s or 70s until present day. And what we saw were some of these PFAS compounds, perfluoroalkyl substances. And these can be formed by the degradation of volatile chemicals that are used in numerous types of consumer products. And what we saw was that we didn't see too much actually until about 1990, after which we saw huge increases in all of the chemicals that we were looking at. These results were really interesting to us because the fact that we had temporal trends means we can do a bit of environmental forensics to figure out where these chemicals are coming from. And what we actually saw was a really strong relationship between the deposition of these chemicals and changes that had been made due to the Montreal Protocol, which was enacted to protect the stratospheric ozone layer. So phasing out chemicals that destroyed stratospheric ozone, phasing in chemicals that did not destroy stratospheric ozone, but may have other environmental problems. So the chemicals that we found, these PFAS chemicals, are extremely persistent in the environment. They have no known degradation pathway. And so they will persist in the environment for the foreseeable future. The extent of the increase to me was really, really surprising. So I've never actually encountered a performance chemical where we can do a replacement. We have a problem, we replace it with something else, and that new chemical is totally perfect. And so in the case of the Montreal Protocol, what we were seeing was protection of the stratospheric ozone layer and climate, both extremely important. But what we're now getting is this deposition of these persistent chemicals, and it seems to be happening globally.